Okay, hello everybody. So today we're going to begin our discussion in Chapter 6, Section 6. And what Chapter 6, Section 6 deals with is solving systems of linear inequalities by graphing. So there's a lot in that sentence of what I just described. So let's take a real quick look at what that actually is. So it says solving systems. If you think back what we've done in the last quite a few videos, we have been solving systems of linear equations. And with a linear equation, one of three things can happen. You can graph them and the lines can cross in one place. They could graph them and they could be parallel, in which case they don't cross at all. Or you could graph them and they could be the same line, in which they would share all the points and there would be an infinite number of solutions. So we could have one solution, no solutions, or infinite solutions. Well, when we graph linear inequalities, not linear equations, but linear inequalities, not only do they have a line graph that either has to be a solid or dashed based on what the sign is, there's also shading that goes along with those because they're an inequality. So we have done this in prior sections where we've graphed linear inequalities. What we're going to be doing in this section is we're going to be graphing more than one linear inequality at a time on the same coordinate plane, and we will then see if the shading overlaps. So let's take a look here. So what you see, and this is a little tricky because the notes themselves are in black and white, but if I were to use two different colors, I could use, you could see I'd use black there, and then all the shading for this black line would be over here, right? Now the second line that I have would be this straight line right here. It's a solid line, and I'll show you why the difference is. And then that graph is shaded over here. And what we end up with is a region where the shading overlaps. The black shading is overlapping the red shading, which is all this area right here that you see me making blue. And in that region is going to be where a solution to the system of linear inequalities will come from. And sometimes the shading won't overlap. And that's what this is showing you right here. So it says a system of inequalities, a set of two or more linear inequalities with the same variables. A solution is the set of ordered pairs that satisfy all of the inequalities of the system. So again, in this case, I'm going to highlight in blue. This is where the shading overlaps from the two separate graphs. So that's therefore where you would find a solution. If you look at the second one, we have two lines that are parallel, and the shading for each of the lines is on the opposite side, and the shading doesn't overlap. So what that would mean in this case is there would not be a solution. So there's really only two cases that can happen here with systems of linear inequalities. Either you can have infinite number of solutions like this, or there can be no solution. And what you see there is a zero with a line through it. That means the null set, which is nothing. So there's no solutions or infinite solutions. So let's try solving one of these. So you can see I have two linear inequalities. Both of these inequalities are in slope-intercept form, which, if you don't remember, is y equals mx plus b. I'll just write it there. We always start by graphing the b first. I'm going to go ahead and graph this first one in red. So I'm going to go up 1 and put a dot. And then my slope is down 2 over 1. And I can do that a couple times if I want. And you can see that the points line up nicely. You do need to keep in mind that this is a strict greater than. So when I go to graph this, this would just be a dashed line. So it would be a dashed line through all those points like this, okay? Put arrows on the end of our line. Now, the last thing that we need to remember, and this is probably the most common thing that students forget, is that you need to shade. And so this says the y needs to be greater than. So right here, our dot was at 1. We need to shade where the y's are greater than 1, which in this case would be above this line like this, okay? And so what you see is we have the shading for that first graph. Now our second equation is a little different. This equation right here is y is less than or equal to x plus 3. So I'm going to go to 3 and put a dot right there, and then I'm going to go up 1 over 1, and I'm going to continue to do that a bunch of times just so I get a bunch of points I know how to line up when I draw the line. Now in this case, because it's a less than or equal to, it's going to be a solid line, and so I would do something like this. Okay, so there's my solid line. And then the last thing, once again, is to do the shading. In this case, we want the y's that are less than where we cross. So we crossed right at 3. We want to shade where the y's are less than 3. So all the y's that are down here are less than 3. So we're going to shade below that blue line like this. Okay. Now, what you see is I end up getting an area where there are the shading overlaps, and that overlapped shading is where your solution will come from. Now, there isn't one right answer because there is an infinite number of points there. But if I were to pick one, I don't know, let me get, let's see, what would be a good color that you'd be able to see? How about maybe yellow? If I'd pick right, let's go right here. You guys can see where that yellow dot is, right? That point, that ordered pair within the shading would be the ordered pair 2, 1. Okay. Now, what that means is this ordered pair would work for both this equation and this equation. It will work for both because it is in the shaded region. If I were to plug the numbers in, I would get a true statement. So I'm going to show you that. In the first, y is greater than negative 2x plus 1. If I put the number 1 in for y and the number 2 in for x, I would get negative 4 plus 1, which is negative 3. So it says 1 is greater than negative 3, and that is true. It worked. Now, if I take the second equation, and again, I'm going to put this ordered pair in 2, 1. So 1 in for y, 2 for x. 1 is less than or equal to 5. Once again, that is true. So as I said, the overlapped shading is where you will pick your ordered pairs that will work for both of your inequalities. So we're going to do one more. I'm going to show you how to graph this one. This one's a little bit different because it is a special case. In case you've forgotten, this first one, y is greater than or equal to negative 4. That is a horizontal line, in case you've forgotten. So that means you just simply go down to negative 4 and you put a dot. And in this case, it would be a solid line because it's a greater than or equal to. So we're going to put our solid line there and draw our arrows. The last thing that we need to consider is it's a greater than. So we need to shade where the y's are bigger than negative 4, which would be above. So we're going to shade it just like this. And we got it. There's our shading. Now, the second equation is in standard form. The easiest way to solve that, or to graph it, excuse me, is going to be to solve it for y. So I'm going to go ahead and move the 3x over to the other side by subtracting it, and I get y is less than or equal to negative 3x plus 2. Now, the reason why I did that is it is now in the slope-intercept form, so it's easy to graph. So that one you would go up 2 to put a dot right on the y-axis at 2, and then you would go down 3 over 1, just like that. Put a few dots there. We can count the slope out more than once. It would be a solid line. It would be a solid line. So we would go ahead and draw our solid line through those two, just like that. And then we would need to determine where our shading is. And in this case, it says y is less than. So we're going to shade below the line, which in this case is all over here. Okay. So our shaded, our double shaded region, if I were to get some yellow here and highlight it, the double shaded region is going to occur in all of this area right here that's yellow. That's where our overlapping is, and that's where our solution ordered pairs would come from. So there you go, guys. There's our first video on Chapter 6, Section 6. I hope you understand it. If you do have any questions, feel free to email me. Have a great day.